Allow me to talk about GloFAS, the Global Flood Awareness System. Basically, last year's talk, what followed up, what have we done in the last year. I'm Ervin Zsoter. I work at ECMWF as one of the flood group colleagues, and we work together with the Joint Research Center developing this system. Basically, GloFAS has been used for many years now, and I guess probably most of you have either used or know about it. We complement, as we say, we complement national and regional system. So basically, it just helps where nothing better, as easy to say, that is available. It's freely available for absolutely anybody and for absolutely any type of use. Currently provides hydrological ensemble predictions of 5 kilometer. That's the new version, daily time steps, updated everyday ones. We provide flood forecasts and flood risk of hydrological forecast up to 30 days. And also there is a seasonal component running out to few weeks with lots of usual information provided, graphs, hydrographs, antecedent precipitation conditions, and also flood risk. Usual website with lots of products and also data services and web services, the usual lot, but that's actually quite important as you will see. So interesting point, how do we model hydrology in GloFAS? I mean, in the center, it's LISFLOOD. It's a traditional hydrological model, which hearing Grace talk yesterday and also having discussions also at ECMWF about AI and machine learning. I wouldn't be surprised if this is replaced relatively soon. It seems that AI is possibly the future, but I don't want to get into that. We use lots of methodological data produced by ECMWF, so we utilize the ECMWF NWP infrastructure. Ensemble, 51 ensemble members, up to 15 days, the extended range, and also the seasonal forecasts to actually support and force our seasonal time scale. We have ERA5 for the climatology, for the historical conditions, and also for the 30-day system, we use that to reduce the flood thresholds. We rely on ECMWF usually infrastructure, so Mars is the methodological archival system, and CDS, the Copernicus Climate Data Store, as I didn't mention, but GloFAS is part of the Copernicus Emergency Management Service, as Andrea introduced yesterday, sitting alongside the global flood monitoring system in the flood pillar. So CDS we use to actually provide all our discharge data currently, which will be extended probably next year with other variables to all the users. So basically all our data is available there. Everybody can download it at the website and also web services, etc. It's a long story. GloFAS started out around 2011, so around the time when EFAS, the European, the probably more solid and supported by partners system, started its operational service. First, it was just an action of few enthusiasts who wanted to extend it on the global scale. At that time, it was using ECMWF's own runoff, so produced with the land surface model. And throughout the years, for example, 2018, when we introduced it operationally, that's when it actually was funded for the first time. From 2018, it's more and more kind of like an acknowledged service, and it was kind of ramped up. A few other important updates, and the latest one just happened recently in July when we introduced the latest version 4.0. And I'm just going to introduce basically what have we changed. Probably the flagship change is going from around 10 kilometers to 5 kilometers, so hence the title of going into the hyper resolution or our buzzword. But probably more importantly, all the maps that GloFAS sits on were completely revised and regenerated. So all the catchment morphology maps, land cover, land use, or soil property maps, for example, water demand, because there is a water abstraction component. So everything is new, obviously using the latest better information. And I personally think that this had really a major impact on the model. And that's, I forgot to mention that this one is developed mainly by JRC. So it's JRC's, the Joint Research Center's in-house hydrological model. So for the high resolution, we needed obviously accordingly the metallurgical forcing. We had to reproduce everything from R5 downscaling with some orographical correction. And from the high resolution, it's important to mention that ensemble resolution now changed just recently from 18 to 9 kilometers. And the list plot model had to obviously update it a little bit, probably larger data volume, and we're talking about petabytes of data, basically in total, including everything. So we had to revamp a little bit the IO and the new calibration. 14 parameters, the usual traditional hydrological kind of like calibration with station data, around 2,000 selected stations we could use. Another major task was to regenerate the flood maps. GloFAS provides some, they call rapid risk assessment, and it's not dynamically computed because it's impossible at the moment, so no computer cloud. Even a ECMWF would allow that. So we use the risk-adaptive model and we produce this flood map catalog currently on 90 kilometer, 3 arc-seconds. So it used to be 1 kilometer. So this is kind of a big jump. GloFAS places itself as a kind of larger scale flood prediction system, reflecting that the minimum area is 500 square kilometer here. What's probably important, we do it in real time. So basically for the real-time forecast, we produce a real-time flood risk assessment using this graph, taking the river discharge, return period, prediction, the median in particular, and get the right flood maps that correspond and blend them into one flood area. This highlights the 100-year maps of the static map, which is also on the website, and maps are only produced from 10 years because there is quite a lot of uncertainty of it as we go lower return levels, return period data. We produce a lot of data. So that's probably a strong point of the service. So there are 5 different data sets, and all these data sets, all the river discharge is available in the Copernicus family data store in the CDN. So everybody can go and download. It's not 24/7 supported. So for any time critical applications, people come to us and then we send the data through the FTP service. So you send that the usual FTP system that disseminates all the data, metallurgical data, and in this case also the hydrological data. So we have the reanalysis, the real-time forecast, but also we produce an extensive data set, reforecast data set for the 30-day component, as well as for the real-time seasonal system, the seasonal reforecast going back to 1981. The medium range of 30-day reforecast usually cover a year, but go back to 20 years. So for the past 20 years, these forecasts are produced with the latest model using ECMWF methodological reforecast, which provides kind of like a lot of data to post-process or do verification. So that's basically the use of it. And ECMWF went high resolution with other changes as well. The latest cycle is 48R1. It's important because of the big change and especially the higher resolution. So we couldn't do this usual, we produce the whole year and provide everything at once. So we had to kind of start only at the end of March. And as we go along in the year, we will produce these reforecasts. And everything is on CDS. And also we carry on when it's a major model upgrade and run the previous model, just in case any user really wants the continuity. But we obviously encourage everybody to use the new model. So how good is GloFAS? I mean, it's a traditional hydrological model. I would say it's pretty good, at least over a large area of the globe. It's represented by the modified clean group efficiency. So you see the purple areas, especially the dark purple, which is above 0.9, the little lighter purple, 0.7, all the northern hemisphere, Amazonia, some other catchments areas. The scale is pretty good, pretty high. And then we go into the drier area, like the southern, central, North America, USA, and sub-Saharan Africa. Usually the tropics is more complicated and probably coming from the precipitation. But the tropical areas is not as easy to predict. And so the skill drops, and some areas like the yellow represents no skill in terms of the KHE. So even with the best that we could come up with. There are areas where we struggle to actually represent the processes, and precipitation is probably not good enough. This uses all the data that we could basically use even with 1 year to give a first estimates on the quality. So how do we compare with the previous model? Version 3 or 3.1, as the pre-analysis had this version. I mean, as you can imagine, it's a big lead. So the lines, the cumulative distribution function, the purple is much to the right, means on average, we really improve a lot. So again, the kg, the 3 components, and simple timing score as well used. So the major contribution is the bias. So the bias got seriously reduced. Maybe a little bit disappointed that the correlation, kind of like the timing, didn't improve more, but all the other components kind of also improved a little bit. But as a whole, the median kg jumped from 0.31 to 0.65. So now I think GloFAS is kind of like a well-established system in terms of quality, and there are the AI models, of course. So that spurs kind of the life up quite a lot. So at the end, I'd like to just demonstrate GloFAS and the products on 2 of the most recent flood events. These happened in September. So one, Libya, the devastating flood we already heard mentioned this week. And the other one, which I highlighted, is the Greece floods, which also happened in September, the beginning of September. And it happens, this was caused, both systems were caused by the same storm system, this Medicane, Daniel, very unusual and a little quite worrying, actually, especially for the future, what can happen. So in both cases, extremely unusual precipitation was observed. Greece, 700 something millimeter in 24 hours, which is really a lot for a European area. And also Libya, over 400, if you believe, was observed, but maybe more. And this is really incredible. And the model was pretty good. The methodological model still very much underestimated it, but still the much lower values, predicted values, were super extreme. So nothing really seen in the model climatology, which takes ensemble, lots of members, lots of focus ranges. So it was really a proper event. And what GloFAS basically showed, in both cases, basically when 5-ish days ahead, we first showed a signal, or kind of like a solid signal, maybe in this case not on the right river catchment, but fair enough, we basically had some strong signal. And kind of 2 days earlier, 2 days before actually the party, when the signal really shot up, really kind of saturated into the several hundred years, basically unprecedented in the model climatology, you could say, so uncharted territory, which obviously happens, but usually in very dry areas where you only have 1 or 2 events in 40 years, and it's really nothing you can estimate what's the return period really. The flood risk kind of indicated the right area, obviously not pinch perfect. The grayer area is the model, and the lighter blue area is the flood monitoring on the 7th, and from the 6th, basically the flood kind of started spreading, and the risk assessment with the exposure, number of people expected to be impacted, really points to the right area. Not surprising, because we obviously match the estimated inundated area with the people and the infrastructure. And then finally, the video example, pretty similar. If you are familiar with the event, so Derna was where basically hell broke loose, but that mainly was due to the 2 dams breaking. And even without the dams, it would have been a devastating event, without any doubt. With that much water coming down, it just was impossible to withhold. And 5 days ahead, strong signal, but still a lot of uncertainty. And as usual, very extreme events, we don't expect the model to predict it too far ahead. So 2 days, roughly, strong signal, all the areas that we believe were impacted come out. This hand is probably even more extreme than the Greece example. And again, the flood risk, inundated areas, as much as it could be actually estimated by the satellite, or the Copernicus satellite, you can see from the 2nd to the 12th, and the 12th, all this, as again was mentioned, lakes were formed. Pretty much, I would say, matching what the model estimate is. So I'm very pleased with this. I mean, probably the people there were not pleased as much, but unfortunately. So then finally, what do we plan? So I mean, we are honestly very tired and have a major upgrade with resolution upgrade in the meteorological system, coinciding with a major upgrade of the global system. And at the same time, we also had a major upgrade on the European system. So we had a hell of a summer. I can safely say that. Having an upgrade in July, I mean, we still blame JRC a little bit for asking us to do that. So the next one will be a minor upgrade, obviously, with a little bit of fine tuning in the products. And probably a little bit more major, we plan to archive more variables in the CDS, and so basically provide to the users soil moisture, snow runoff on top of discharge. Also, we plan to have a critical infrastructure impact layer in the flood risk, so basically pinpointing where the hospitals and other infrastructure items can be impacted. So, a very last, please contact us and collaborate with us if you haven't done yet before. We have points on the web at the moment. This is how we could provide information, kind of like detailed information, hydrographs and precipitation, posting, and all that. And we need users' points, so where observations are available, or it's just a point of interest. So we are happy to ingest anything. There are areas where we don't have these fixed points, which we always provide. I mean, if there is a flood condition, then we pick our own points and basically show these dynamically selected points. And obviously, if there is anybody who can still share some data, that's even better. Like Google obviously also mentioned that, and calibration, verification. So we rely on data as well. And we are very happy to see all your studies. Anybody who used GloFAS or feedback or anything you can share with us would be very welcome. So thank you very much. Thanks, Ervin. Impressive work. Are there any questions? Hey.
Classic hydrological modeling question. Do you have a sense of the source of bias? How much is it coming from the meteorological forecast?
We couldn't, unfortunately, there was no time to really trying to disentangle where it's coming from. So personally, I think that most of it is the precipitation, especially low scale areas. So we have lots of issues with that. But another impression is that in quite a few areas, I don't trust the observations, or I don't trust whether the observations represent really what exactly and what's the contribution of like the water abstraction. So how people use the water. So that could also cause mismatch with the models. So sometimes you're not sure whether you should trust the model or how much the observation. But if we trust the observation, then maybe also the hydrological processes. So in wetlands, for example, we can't really do. And as we go for a higher resolution, like lateral flow would obviously become very important, which we don't represent at all. So yeah, precipitation probably more, but as we go for higher resolution, more and more the hydrology.
The Southwest US, it's you see that all the models.
Yeah, I'm not surprised. So it's a difficult area.
Wonderful talk, Ervin. That was great. I know that you guys are mostly focusing on larger river systems, but you have underneath also, or under the hood, you're also working on getting more information from smaller headwater streams, is there any plans on making that more operational and making that available?
I mean, the data is for absolutely every pixel. So we don't distinguish larger catchment or the smallest ones, down to the few square kilometers. So everything out there. On the website, we don't color the rivers. So the river network is there, down 250 square kilometers, kind of like for practical reasons, because with large file is more difficult to plot. And we don't recommend users to basically really rely on the very smallest places. But now a few hundred square kilometers, I think that's where you can start, just like the flood risk, as I mentioned, 500 square kilometers. I mean, for some people, this is really large catchment. I mean, depends on obviously your scale, but for us, it's already very small.
So it's really for the emergency management team that relies on this, that they are well, it's not even mandatory, right? It's kind of guidelines. They should at least look at the data for larger scales, but not for smaller scales. Do I get that right?
I mean, I would say that everybody should look at all the data. I would not tell users, please don't look at this data, but please just be aware that especially some areas the scale is low, and also other areas maybe very small catchments, you can't rely maybe that much. But in areas where the model is very skillful, I wouldn't be worried much about the small catchments. And where the model doesn't have scale, I wouldn't worry because it doesn't matter the size. I mean, it's just not there.
Okay. I'm not sure question.
Yeah, just a short one. I was a bit surprised to see that you showed the difference from 3.1 to 4. The skill seems to be degraded in Europe, which is a bit very surprising.
I purposefully didn't mention.
Yes.
I mean, for me, it means that any system that you want to improve, I mean, it's inevitable that you will deteriorate somewhere.
Right.
And that's something that, I mean, the calibration for GloFAS is still done or was done by JS. ECMWF is calibrated ECMWF, but they really did the best they could. And I think it was really, I remember discussions, they were trying to look into why, and this is how it came out. But luckily, it's not a major deterioration.
But they try to then optimize across all applications. Yeah. Okay, that
all stations, but in fairness, each station, more or less of catchment in its own right is calibrated. So it's not like a regional approach. There is a regionalization, by the way, I didn't have time to mention, which basically tries to kind of extract the calibration goodies into areas where it's engaged. But it's not a proper regionalization station.